afternoon and good evening to our global audience, and welcome back to our final day of the Transition Faster Conference. Let's talk wind. Yesterday was another packed agenda where across 4 sessions we heard global experts discuss the importance of digitalization, the role of data, and how policy will be at the heart of how the renewable industry progresses. The program so far has covered the opportunities and challenges around technology, investment, and policy. However, I think that it is a challenge of having the right mindset that we also need to address. How can we use strength from other industries to progress the transition? As I said on day 1, while speed is needed, the energy transition is high risk and complex and crosses many sectors and borders. While we are making great progress with the implementation of renewable power, DNVGL's energy transition outlook shows that we are far from being ready to meet the goals as set in the Paris Agreement. To be better prepared for this task, at DNVGL, we have recently decided to establish a new business unit focused on decarbonizing the energy system as a whole, including wind, solar, storage, power, oil, and gas, creating a new combined unit, Energy Systems. Sector coupling is currently seen as an important enabler of the energy transition through electricity and other value chains, such as natural gas, oil, hydrogen. We are more tightly connected, forming one large, interconnected, and increasingly dynamic energy system in the world. This leads to market coupling as well as sector coupling, and market coupling, an aspect of sector coupling, may well become an important driver to keep investments in renewable energy sources, such as wind turbines, economically and feasible. Renewable generation suffers from cannibalization effect as the price they capture on the electricity market decreases with increasing penetration. Sector coupling may prove itself to increase the value of renewable electricity during hours of high renewable production. From an industrial point of view, sector coupling is an opportunity to reduce cost. A typical example is fuel switch from industrial heat steam production in Denmark, my home country. District heating is a good example of sector coupling. Denmark is known for its high contribution of wind energy. It has also a strong history of coupling electricity and heat. 65% of its population is connected to district heating, fed by combined heat and power generation. The Danish government recognizes this connection and removes legislation and tax barriers for integrating electricity and heat demand. This will benefit both the heat and wind sectors in Denmark, as the opportunity cost of avoiding using, for instance, natural gas in district heating may see a bottom price for wind energy during surplus production. In our final days program, we will look at the role and importance of sector coupling in enabling a faster energy transition. We start with a session on grid integration. Wind farms are rapidly growing, and we will soon assume a dominant position on the electricity supply system in several markets. The responsibility to ensure the stability and reliability of the power system is gradually shifting to wind farms as the technology dethrones incumbent technologies. In this panel, we will explore how wind farms connect to the power system, hearing from the Deputy Manager of Electricity Coordination at the Chilean National Control Center. We will discuss how wind farm connection requirements can differ from thermal power plants, and whether this difference has contributed to any power outage. The Deputy Manager will also discuss the motivations behind Chile recently introducing an auxiliary service market to procure grid services. We then will look at what's next for green hydrogen. Amid the backdrop of the European Clean Energy Package, hydrogen has risen again like a phoenix out of the energy markets. After a short career in the early 2000s, hydrogen is back on the scene, bringing it with a lot of potential. It is an energy vector that could lead to the decarbonization of the hard-to-abate sectors. High-power transport like trains, heavy trucks, or even ships and planes could be hydrogen-powered. Next, we will explore what the role wind could potentially play if we fully utilize the technology. The team led of Grid Integration at Enercon will help us understand the ultimate performance a wind farm can provide for frequency, voltage, black starts, and inertia. Several promising pilot projects and trials have been conducted that showcase how flexibility this technology can give. And given this, we will consider whether wind contribution to system support is enough to meet the entire needs of a power system. Looking to the future, we will discuss how grid codes, interconnection requirements, and demand flexibility could change the way wind farms interact with the grid. What we have seen is that grid codes are tightening. Interconnection requirements are favoring centrally planned approaches, and demand flexibility could be a disruptive technology. Finally, in the last two sessions of the conference, we will look at the role battery storage will play in securing a renewable future, and more specifically, looking at how the US have led the charge in global energy storage deployment. We are looking to ways to connect with new industries and forge long-standing partnerships. We are entering an era where collaboration, data transparency, and trust are becoming the new commodity. Now more than ever, we need to collaborate, to share our best practices, solutions, and ideas, and work together to transition faster. I hope you enjoy the last day of the conference with this collective view in mind.